Okay, good. Let's start. It's me. I'm head of engineering at Zalando, and I'm one of the dinosaurs. I was thinking about putting the small dinosaur icon there, and I can talk about this. So I started at Zalando 8 years ago, so I saw how a small startup became a wonderful company. Data. When we're talking about data being a new oil, or being a new commodity, or being a new whatever, we have to talk about what data is and how it is actually processed, and how we think about it. But before that, I want to give you some data about the context where my company is coming from. Of course, without a little bit of advertisement of Zalando, it will be impossible for me. So I will not be reading the numbers. I hope you are impressed by the wonderful performance of our corporation. 14,000 employers, 2,000 technology employers, and about 200 data scientists. We have technology offices in the following locations. I'm doing presentations for since years, and for quite a long time it was just Berlin and Dublin, and then Berlin, Dublin, Helsinki, and then Berlin, Dublin, Helsinki, Dortmund, and then Berlin, and so on and so on. Now, I think at some moment I will have to reduce the font size. Okay, data. So we're talking about data generation, and you from all your companies, I think you all know how the data is generated. It's coming from everywhere. We'll be talking about data processing. So we, from different teams, from data engineering teams, from all kind of teams, actually all teams are processing data. Everything that we do from the technology point of view is data processing, more or less. And data consumption, okay, there are some teams that are better or different than others, and they consume more data than others. They don't just process the data, but also consume the data. And I want to, so the flow goes up, and this is one of our halls in the warehouses that we operate. I think this is not as impressive as robots in the BMW warehouses, but it's still a lot of sensors and a lot of robots and a lot of efforts that we spend with our teams to optimize the performance of these systems. So, data is the new oil. I started to research a little bit where this old-fashioned term comes from. Actually, the first statement is from not from 15th century, but from 2006. And it's more about really putting the analogy of the data as some kind of resource that we processed and generating new value and generating new valuable entity for our businesses. During the research, actually I found out about this guy. The Piero Scaruffi is, if you look and open the Wikipedia page, it looks like, whoa, I didn't think that this kind of people still exist. So they all died in 16th century. He's like Gauss, he does everything. He writes poems and also thinks about data processing in automobile industry, as you see. So why I decided to put this citation in the presentation is because he says not only we generate new valuable entity, we generate new data. We are increasing, we are putting this cycle of data flow and increasing the amount of data that we have in our organizations. So we more or less have the stream going from both directions. our teams that process and consume data, they generate new data for consumption by other entities and by other teams. So, I saw this interesting hierarchy of data needs. So this was presented, I think, last year by Monica Rogati on one of the conferences in the US, and I liked the structure of these needs. So this is really, data is like food that we consume further on, and at the top of the pyramid is artificial intelligence, is deep learning, is automated decision making. So, what else? Yeah. So we are more or less able to map this flow that I was talking about, very high level, from up to from bottom to the up to this pyramid, and we see that actually what we are concentrating on, why we do everything that we do in the base of this pyramid, is really AI, deep learning, and automated decision making. And in Zalando, having people who are dedicated to these tasks, we actually started to finding out what makes their life difficult, how we can make this most important peak of the pyramid be more efficient. So we made we talked to them, we collected information, and we made a lot of interviews with data scientists and research engineers at Zalando. And the results were quite shocking. 80% of perceived energy of data engineers, trained data engineers, machine learners, deep learners, statisticians, is invested into data engineering. And not all of them actually like this work. So, and I think we are approaching the core message that I want to give in this presentation. Data scientists and data researchers are not data engineers. Data engineers are not data scientists. If you have this kind of profile that combines both of them, yeah, you have the unicorn. Yesterday it was mentioned on one of the presentations. But unicorns are rare, and it's difficult to scale unicorns in the companies. So, my advice, of course, it should be like this. Yeah, so I couldn't find the right font for that, and spent probably 15 minutes searching for the font. But sorry for not really nice message, but it looks quite as it should. It's a patented font, actually. Hire data engineers. Okay, now I have some time in talking about what data engineers are and why and how they are different from data scientists. Actually, I'm speaking so fast, incredible. Data engineers. Okay, so imagine a data engineer. Close your eyes. Everybody close your eyes. No, you're not closing your eyes. Okay, good. We're in Germany, nobody closes eyes. Okay, now look at the screen. This is your typical data engineer. It's a plumber. And being a plumber is a not bad thing, it's not good thing, it's just we need plumbers who are bringing things together, who are taking elements, who are taking pipes, they connect the pipes, and they let liquids, in some situations maybe chocolate, I don't know, I suppose that chocolate factories also have plumbers. Maybe I should change my work and my career to get to the chocolate factory as a plumber. Yeah, never thought about it. It just came to my mind now. Okay, good. But the data engineers, of course, not using the metal pipes. They're using technologies that are known to them, and these technologies are so complex in themselves that learning how they work takes years. So you cannot expect any data scientist who is trained to do machine learning, who spent and invested a lot of time in understanding how to control and how to make the models run correctly, to know everything about technologies that are needed for plumbing things together. So data engineers have to be specialized and have to know how to operate, how to glue together, how to bring things together, how to make this plumbing not to leak. Because if the plumbing leaks, if the pipes are blowing up constantly, as we probably all experience in our careers, and probably on the fuck-up session later today, there will be a lot of discussions about broken pipes. What? I forgot forgot how to speak and how to breathe. Okay. Next. Yes, of course. Zalando made a decision 3 years ago to move away from the data centers into the cloud. We invested completely into Amazon Web Services. We are currently in discussions with Google Cloud to do some parts of the work, especially data science related, in the Google Cloud. Our team is working on the Kubernetes for AWS project as an open source project to enable our teams to run things on AWS and then also, if needed, migrate it to Google Cloud. So I think also these environments, though they are very well documented, also need a lot of knowledge, also need a lot of understanding how to run them. So the data engineers that you have and you train and raise in your organizations, they also need to know how these things work. So now I have a little bit of time to talk about data engineering at Zalando. So at Zalando, we, being a relatively big organization, so when I started at Zalando, it was a small organization. Okay, I started in the technology organization that was probably 40 people. We were all fitting in a small room in one stand-up every morning. And now the only technology roles, it's about 2,000 technology people at Zalando. This is really a big technology powerhouse. And we have hundreds of teams who autonomously deliver products, who autonomously hopefully deliver value to customers. I'm sure that all our teams are delivering value to their customers. But all of these teams need some core infrastructure. So we have created, for years we had a platform department where we were controlling, for example, databases, where we were controlling the deployment systems and so on. And now we have a relatively big department that is called Digital Foundation, where we have different areas, including the systems for deployment automation, including data lake, message bus. They will be talking about it a little bit more. And about all other systems that would be useful and to make things easier for the teams to deliver and to not to spend time on plumbing than providing value and solving the business problem. Because all these things are not really business problems. These are technical problems that shouldn't be there in reality. So we took the very old concept from 16th century about the data lake. I think this is very nice concept. You see data being delivered to the data lake, cleaned up, made it nice, and then processed by the data scientists at the separate table. And plumbing also, but of course we couldn't rebuild it exactly how Lucas Cranach envisioned it. We did something else. So not something else, but very, very much influenced by old German engineering. Microservices. I will have a small step back and say, okay, together with decision to go and invest completely into the cloud, we also made a decision to say that, okay, to ensure that our teams can work autonomously, these teams should not be contributing to one monolith or parts of a monolith. So they all have to have clear ownership of their microservices. So the microservice architecture was embraced. We said that we will standardize not on the technology level as before, but on the level of the RESTful APIs. So we have not 4, but about 1,500 microservices now in the company, and they all have different characteristics. But I think the two biggest classes of the microservices are microservices with persistence and microservices without persistence. We saw that peer-to-peer connections wouldn't work between microservices, and this is known actually. Yeah? So we started thinking about the solution of the problem of data integration. I made several talks, I think 2 years ago, about the core reason why we went and invested a lot into our event bus infrastructure. But here I will mention it very shortly. So we thought that we need the corporate event bus. We saw the examples of using Kafka, and we are quite excited about Kafka-like systems. But being publicly traded company and big company brings in a lot of responsibility. And this responsibility also means security. It also means compliance with legal requirements of data processing and so on. Back then, and mostly now as well, Kafka is not really built for these requirements. So what we added on top of the Kafka, we simplified the clients, we added security level, we added re-partitioning levels so that we don't need to shut down everything if we need to put another cluster close to migrate and so on. So we more or less masked Kafka away and created Nakadi Event Bus. This is really impressive project, and not only because I initiated this project, of course only because I initiated this project, but okay, it's really very cool project, and if you haven't seen it yet, probably you haven't, I will definitely recommend you go to our open source GitHub page and see Nakadi Event Bus. It's really provides nice tooling for controlling your Kafka, and if you will not use the metadata store and the schema validation and security systems, you will be able at least use parts of it that actually control the Kafka clusters in AWS environments. So, long story short, we define that every microservice, if it needs some data to be shared with other teams, should send this data over the centralized Nakadi Event Bus point. So this data should be there. And then it's the task of the data lake team and infrastructure team, packed with highly qualified data engineers, to extract this data, materialize it into the data lake, and provide it for other systems, including business intelligence and including the teams that are data-heavy teams. So this would be machine learning teams, and I love this term. If you don't know this term, it's really the best word to say to your executive. DDDM, data-driven decision making. This is, I think, should be the word of the year. It was in 2017. Okay, I'm always out-fashioned. Sorry. DDM tools, for example, this would be any enterprise-like monitoring of core KPIs. This would be the tool that enables data-driven decision-making. Or the DDDM tool would be even recommendation engine that fetches data from the systems and sees which data will be the best to which products will be the best to recommend is more or less the DDDM product. Many products that we run here are these kind of products, and exactly this is the reason why we decided to go into to invest so much into the standardization on data exchange and standardization of data storage. So I think I was shown that it's more or less no time for me to talk. And to tell the truth, I was thinking a lot about how deep this presentation can be. In the beginning, I thought I will be talking only about high-level stuff and why data scientists are not data engineers. But then Alexander said, well, we created this conference because we wanted deep kind of technical talks, and I thought, oh Lord, I have to add something into the presentation that will be at least a little bit deep. So I suppose this is a little bit deep. But anyway, I'm here until the end of the day, and I think that it will be better if you have any questions about deepness, and we can go as deep as you need to discuss it now and in the very short time of questions, or afterwards when I'm here. And yeah, so these technologies are actually the technologies that we use for building our stack, more or less our data lake and our event bus. And these are the links to our open source projects, to our API guidelines, and also about our open source principles. And of course, if you have any questions, you can ask them here, or you can start working at Zalando, and there you will get the answers to all the questions that you got on this presentation. So please go to this URL and check out the open positions. There are, I think, about 250 open positions in technology. So, and I'm searching for now, sofort. Okay, anyway, any questions that I can answer in 5 minutes?
Yes, I do have a question regarding Hi, I do have a question regarding the deep tech you just talked about regarding Nakadi. Did I get you correct that you're accessing Kafka exclusively through an HTTP interface? And if
Correct.
yes, how do clients get data? Are they polling data through an HTTP interface, or did you implement something else there?
So we implemented the API that actually streams the data. So when the it's kind of so it's HTTP, but it's a pseudo REST. So it is REST until it's not REST, until it streams. So you connect to the system, and then you get unlimited amount of data until you close the connection.
So post request response, okay.
Yeah. So everything other than this is REST. So RESTful HTTP system.
Hi.
Hi.
My name is Alan. I'm from Austria. I'm working at a bank, and we have most of the tools you just showed. One of them particular is very interesting, I think, because it's also made in Germany. It's the new star in the big data sky, I would say, which is Flink.
Yes.
My question would be how you're using right now Flink, or for which purposes, because we would like to implement it as well in our infrastructure for maybe streaming topics.
Flink. We even have a blog post from 3 years ago on this website, jobs website, where we compared Spark and Flink. Of course, this was 3 years ago. Now many things changed. Back then, Flink won radically in comparison to Spark. Unfortunately, fortunately, I don't know. So it depends on which side you are. I think unfortunately, Flink is not developing as fast as Spark. Currently, in my teams, I'm more or less asking people to think about architectures that would avoid this technology. Though I'm not talking about replacing Flink with Spark, but maybe simplifying it even further by going into the Lambda architecture, where you are kind of feeding events directly from the event bus into some kind of a Lambda scheduler, because in most situations, in the situation of solving most of the business problems, you don't need so many complex things that you would need in Spark Flink-like systems. But of course, there definitely are a lot of use cases. I think the correct way would be not to ask me, but to maybe read our blog post, see how we tested it, test it yourself against your use cases, and see what is better. Yep.
Any more questions? I've got one question. In the beginning, you showed us a slide with data scientists spent 80% of their time being data engineers.
Correct.
And with this architecture, have you been successful to reduce this time?
I don't have data on that for now. So after this, we initiated several initiatives. We started several initiatives. And one of the initiatives is the managed Jupyter cluster, so that data scientists can actually do their research in controlled environment and connect it to the data lake directly. And another initiative is more or less making access to the data lake much simpler than it is now. So now, especially with the GDPR complications, we have a lot of things to do in making data access easier. So, and the work on metadata management system is one of the core priorities for us now, because without understanding where is data, where is personally identifiable data, it's we made very good steps forward, but still many steps to make. Yeah.
So I will ask you next year again when you might be on the stage.
I'm not coming to the fuck up session. No.
Okay. Any more questions from you? If not, then many thanks. Thank you for your presentation.
Thank you for being here.